Hello, 5th grade mathematicians. Welcome to lesson 23, session 2, where we are going to develop understanding of division with unit fractions. In this session, we are going to use fraction bar models and number line models to show dividing with unit fractions. That way you can figure out which way you like best. To get us started and get our brains going, I've got a warm-up problem for you. This is not one of the pages that you can download that would be in your math book. It's only here, so you can do it on some scrap paper. But I'd like you to draw a model to show your answer to each question. How many 1/3 are in one hole? How many 1/3 are in two holes? And how many 1/3 are in three holes? So think about how you would want to draw this out, probably with a fraction bar of some sort. Pause the video, draw it out, and when you're finished, go ahead and come back. All right, I asked you to draw a model to show your answer to each question. How many 1/3 are in one hole? How many 1/3 are in two holes? And how many 1/3 are in three holes? So first, I'm going to draw a model. I'm going to use this as my model. And if I'm looking for how many thirds there are in a hole, I need to divide it into thirds. Here's 1/3, here's another third, and here's another 1/3. So how many 1/3 are there in one hole? There are 3 1/3 in one hole. So now I need to see how many 1/3 are in two holes. Here's one hole, and here's two holes. I'm going to do the same thing I did here, and I'm going to divide it into thirds. Here's 1/3 of my one hole, here's another one, and here's another one. 1/3, 1/3, and 1/3. Now, how many 1/3 are in two holes? 1, 2, 3, 4, 5, 6. There are 6 1/3 in two holes. Now I'm going to look at three holes. One hole, two hole, three hole. I divide it into thirds. This is 1/3, this is 1/3, and this is 1/3. Going to repeat it over here. 1/3, here's another 1/3, here's another 1/3. And for my last fraction bar, 1/3, 1/3, and 1/3. So if I recognize the pattern, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 1/3. And with the pattern, there was 3 here, and there's 3 here 2 times. 3 times 2 is 6. There's 3 1/3 here, and 3 of them here, and 3 1/3 here. So there's 3 1/3 3 times. That gives me 9. There are 9 1/3 in 3 holes. All right, now that we've kind of reviewed a little bit with using these fraction bar area models, we're going to start applying that to our first page, where we are looking to develop understanding of division with unit fractions. And remember, a unit fraction is a fraction that has a 1 for the numerator. All right, so first we're going to model it. We're going to look at area models. So we're going to try these two problems. Gemma made 5 cups of pancake batter. She uses a scoop that holds 1/3 cup to pour batter onto the skillet to make each large pancake. So use the model to show how many large pancakes Gemma can make. So I'm going to get this one started for you, and then I want you to pause the video and finish it out. So it says Gemma made 5 cups of pancake batter. Well, this says 1 cup, 1 cup, 1 cup, 1 cup, 1 cup. There's 1, 2, 3, 4, 5. This represents our 5 cups of pancake batter. She uses a scoop that holds 1/3 cup to pour the batter. So if this is one of our cups, each scoop holds 1/3. So 1/3 of this cup makes a large pancake. 1/3 of this cup. 1/3 of this cup makes one large pancake, another large pancake, and another large pancake. Use the model to show how many large pancakes Gemma can make. So I showed you with 1 cup. I want you to pause the video and go ahead and think about how would she use 1/3 cup, 1/3 cup, and 1/3 cup for each of these remaining cups, following the example I modeled for you with the first cup. After you've labeled that, see if you can determine how many pancakes that she made, and then we will discuss how we can explain why our model represents 5 divided by 1/3. So go ahead, pause the video, complete your area model, and tell me how many pancakes Gemma can make. Okay, Gemma made 5 cups of pancake batter. 1, 2, 3, 4, 5. She uses a scoop that holds 1/3 cup to pour the batter onto the skillet to make each large pancake. Use the model to show how many large pancakes Gemma can make. I started you off by dividing our first cup into 1/3 to represent the 1/3 cup for each pancake. So here's 1/3 cup, second 1/3 cup, and a third 1/3 cup to make 1, 2, 3 pancakes. So then I asked you to go ahead and do the same to figure out how many pancakes you can make all together. If I'm using the same 1/3 cup here and 1/3 cup here to be 1/3, 1/3, and 1/3. Then from the third cup is made up of 3 1/3 cups, 1/3, 1/3, 1/3. The fourth cup is made up of 3 1/3 cups, 1/3, 1/3, and 1/3. And the last cup is made up of 1/3 of a cup, 1/3 of a cup, and 1/3 of a cup. So now that I've used my area model to take my 1, 2, 3, 4, 5 cups and divide them by 1/3 cup scoops, I can see how many pancakes she can make, because each one of these scoops makes 1 pancake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Gemma can make 15 pancakes. So now we need to explain why our model represents 5 divided by 1/3. Well, the model shows that there are 5 cups of batter that are divided into equal parts that are each 1/3 of a cup. And each of those 1/3 cups will be poured onto the skillet to make a pancake. So explain how the model represents 5 divided by 1/3. The 5 cups are divided into equal parts that each equal 1/3. 5 divided by parts that equal 1/3 cup. Now we're going to look at number 2. Suppose Gemma used 1/3 cup of pancake batter to make 4 mini pancakes. Use the model here to find the fraction of a cup of batter used for each mini pancake. So here's our 1 cup of batter, just like these 1 cups of batter. And they've divided into thirds, just as we have done. So there's 1/3, 1/3, and this is 1/3. Each of these is 1/3 of the whole cup. Instead of making 1 big pancake like she did here, she wants to use this 1/3 of a cup to make 4 mini pancakes. She wants to make this into 4 mini pancakes, and she wants to make this 1/3 cup into 4 mini pancakes. So I want you to pause the video and think about, now that this has already been split into thirds, how can we split these thirds to find the amount we would need for 4 mini pancakes. So we already have our thirds. How would we find 4 mini pancakes out of each of those thirds? So go ahead and pause the video and see what you can do with your area model to help you find that. Okay. So suppose Gemma wants to use 1/3 cup pancake batter to make the 4 mini pancakes. Our model's already been divided. Our 1 cup has been divided into thirds. Now we want to use it to see how much of this cup is used to make each mini pancake. So if it's already been divided into thirds, and I know that each of these thirds can make 4 pancakes, I know I'm probably going to be dividing this into fourths. I'm going to go ahead and tile this all the way down. So now this third is divided into fourths for 1 pancake. This third is divided into fourths for 1 pancake. And this third is divided into fourths for 1 pancake. So I'm going to use this 1/3 cup because we want to find out each pancake uses how much pancake batter. Here's the whole cup. I'm going to look at this 1/3 cup first. First 1/3 cup scoop can make 4 pancakes. And I want to look at just one of those pancakes. So I'm going to look at one of those 4. In this darker area here where it overlaps. And we can see our 1 pancake. Each mini pancake uses how much of this cup of batter? Uses 1 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uses 1/12 of this whole cup of batter. So we're going to explain how this model represents the quotient of 1/3 cup divided by 4. We divide our 1/3 cup by 4. So the model shows lines dividing 1 cup into 1/3 cup. So dividing 1 whole cup into 1/3 cups. So here's our 1/3 cup. And it shows each 1/3 cup being divided into 4 equal parts. Each one of those equal parts makes 1 mini pancake. So each part that can make a mini pancake is 1/12 of our whole cup. Each of these parts is 1 of these 12 total parts. Right. Now we are going to model it, but this time with number lines. So this asks us to use number lines to show dividing with unit fractions. So we're going to circle the quotient that matches the question. Here's question A, and we're going to look at which one of these matches. Then we're going to model the quotient on the number line. We're going to write a division equation below that represents our model. So let's look at A first. What is 1/4 divided into 2 equal parts? Is that saying 2 divided by 1/4? Or is it saying 1/4 divided by 2? Let's read through it again. 1/4 divided into 2 equal parts. So that looks like 1/4 divided into 2 equal parts. So this is what we're looking for. Now we need to model this on the number line. I'm going to walk you through this first one because we haven't done this yet. So this is my number line. I know I'm going to need to have it divided, my section divided into fourths. So if this is my 0, and if this is 1/4, and this is another fourth, and 3/4, here's my 4/4, or of course, 1 whole. So now we have our number line planned out. And it says, what is 1/4 divided into 2 equal parts? How do you think I will take 1/4 and divide this area of 1/4 into 2 equal parts? I'm going to draw a line right here and divide that into 2 equal parts. 1 and 2. To figure out exactly what this distance is, I need to do that with the rest of these fourths. I need to divide this fourth into 2 equal parts, this fourth into 2 equal parts, and this fourth into 2 equal parts. So now when I look at that, I have 1, 2, 3, 4, 5, 6, 7, 8. I have now, in dividing my fourths into 2 equal parts, created eighths. So here's 1/8. 1/4 is the same as 2/8, 3/8, on down the line. So I have my 1/8 right here. So if I had this as an equation, and we've got the first part written for us, 1/4 divided by 2 comes out to be how much? Well, each of these sections is 1/8. So now if we look at part B, how many groups of 1/2 are in 4? So which of these two parts of the equation is saying this? How many groups of 1/2 are in 4? Well, what's being divided up? 1/2 or 4? This is how many groups of 1/2 are in 4? So is our 4 being divided into groups of 1/2? Or is 1/2 being divided into 4 pieces? I'm thinking our 4 is being divided up because this is how many groups of 1/2 are in that 4. If I had 4 pies and I wanted to figure out how many halves were in that pie, I think my 4 is being divided up. So we're looking at 4 divided by 1/2. I know that's later going to be part of my equation. So now that I know what I'm starting with, I need to put that on my number line. So if I have 0 here, and my 4 is being divided into halves, then I know here's 0, 1, 2, 3, and of course our 4. It says, how many groups of 1/2 are in 1/4? I need to take each of these between 0 and 1 whole. I know I can put a line here, and that cuts that in 1/2. So I'm going to have you pause the video and figure out how you would label the rest of this to divide this section, this section, and this section into more 1/2s, and where you would put the line. When you finish dividing it up and labeling it, because here's our 1/2, and here's our 2/2, and you finished labeling it, go ahead and restart the video, and I'll finish the problem with you. Okay, how many groups of 1/2 are in 4? We've labeled our number line 0 to 4, and now we're looking at each of these wholes and dividing them into half to see how many groups of 1/2 there are. So here's our first one. You probably looked at this and labeled this the same way, this section the same way, and between 3 and 4 the same way. We have 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2, and 8/2. So how many groups of 1/2 are there in 4? Here's 1, 2, 3, 4, 5, 6, 7, 8. I'm counting 8 1/2s in 4, which is the same as we have 8 halves. So 8 1/2s in 4. So when we took our 4 and divided into half sections, we had 8 1/2 sections. 1, 2, 3, 4, 5, 6, 7, 8 1/2s. So now we're going to take the models that we've used and we're going to connect it. And we're going to make it connections to things we've learned before. We're going to look at the area models. We're going to look at the number lines. What do they show about how the quotient compares to the dividend when you divide the whole number by a unit fraction? When you divide a unit fraction by a whole number. Now, it's been a while since we've done dividing. Remember, our quotient is our answer. Our dividend is the number that's being divided. Our divisor is our number dividing into it. So in this case, we had 4, and it was being divided by 1/2. And the quotient that we got was 8. Our dividend and our divisor. So we're going to look at our area models and look at the number lines. What do they show about how the quotient compares to the dividend when you divide a whole number by a unit fraction and when you divide a unit fraction by a whole number? So if we look back at our area models, and here we have a whole number being divided by a fraction, and we see how many pancakes it can make. And in this one, we have a fraction being divided by a whole number, and we see how much is used for each pancake. Here we have a fraction divided by a whole number in our answer. And here we had a whole number divided by a fraction in our answer. So what kind of connection can you make if you're looking at when the divisor is the whole number, when the dividend is the whole number, and what the answer is going to be when you divide them? You may have noticed that when you are dividing a whole number, so when you're dividing a whole number, by a fraction, or by a unit fraction, which remember, unit fractions have a 1 for the numerator. So when you are dividing a whole number by a unit fraction, you are splitting your whole number into many pieces that are smaller than 1. So you're splitting the whole number into pieces, into many pieces that are smaller than 1. Into parts or pieces smaller than 1. Such as here, we had a whole number. and it was divided by a fraction, and we broke it into 8 smaller pieces, and each of these was less than 1. There's 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. So when we split it into several parts and pieces that are smaller than 1, the answer we get is larger than our original dividend. Which is the whole number. Which was our whole number. Now when you divide a unit fraction by a whole number, I'm running out of space. When you divide a unit fraction by a whole number, like here, we are breaking the original fraction into smaller pieces. So we break that fraction into smaller pieces. So the answer is going to be less than the original number. Now, if I show that with my area model, and we had our whole number being divided by our fraction, we did in fact get more pieces, 15 pieces, which was greater than our original whole number. When we divided our fraction by a whole number, we divided 1/3 cup into 4 for the 4 small pancakes. We broke it in this third into smaller pieces, and we end up with an answer that is smaller than our original fraction, which is what I had here. When dividing a whole number by a unit fraction, you're splitting the whole number into parts and pieces smaller than 1, so the answer will be larger than the original dividend or whole number. When you divide a unit fraction by a whole number, when we break the fraction into smaller pieces, should be we, not when. We break the fraction into smaller pieces, so the answer is less than the original fraction. 1/8 is less than 1/4, and when we divided our whole number, this is we end up with an answer that is larger than our original dividend, and it is 8 is greater than 4. I'm going to make some space here. And I want you to, once you finish writing this, and you can pause the video if you need to finish writing this. Once you've done that, then I want you to again pause the video to use any model. It can be the area model or it can be the number line to find 5 divided by 1/2. And once you've drawn a model that works for you, go ahead and have your answer and start the video. All right, now we're going to use any model to find 5 divided by 1/2. So if you used your area model, probably drew 5 of these. I'm actually going to put the 5th one over here. I'm going to divide each one into 1/2. This is 1/2. This is 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. So if I take my 5 and I divide it in 1/2, how many pieces did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had 10 pieces. 5 divided by 1/2 is 10. I'm also going to do a number line in case you had done a number line as well. Here's my 0. Here's my 5. So I'm going to want to divide up my 5. So I'm going to put my 1, 2, 3, and 4. This is very similar to what we did up here for problem B, where we did 4 divided by 1/2. So we took each of these whole sections and divided them in half. Now let's see how many of those 1/2 sections there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each of these sections is 1/2, just as we had here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again, I took 5. I divided them into 1/2 sections, and there were 10 sections. So 5 divided by 1/2 is 10. All right, now we're going to move on to a little bit of practice. We're going to study how this example shows dividing a whole number by a unit fraction, and then we're going to use it to solve problems 1 through 6. So in our example, it says teams of students in Mr. Reed's classroom decorate rectangular bulletin boards to show their team name, colors, and mascot. Each team uses 1/5 of a bulletin board. The team's decorations fill 2 bulletin boards. How many teams are there in all? So the 2 large rectangles represent the 2 bulletin boards. Each team's decorations uses 1/5 of a board. So each rectangle is divided into 5 sections. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if each team uses 1/5, and there's 2 bulletin boards, how many teams are there in all? If one team uses this 5th, and one team uses this 5th, and one team uses this 5th, and one team uses this 5th, 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 and one team uses this 5th. How many teams are there in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm seeing 10 teams can use this. So from the model, you can write the division equation: 2 bulletin boards divided into 1/5, because each team gets 1/5, equals 10, enough for 10 teams. You also can write this as a multiplication equation. There's 2 bulletin boards. There's 5 columns in each. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 times 5 also gets us 10. Both equations show 10 teams in all. So let's look at our questions based off of the example problem. I want to explain how the model in the example shows 2 divided by 1/5 equals 10. Well, we divided each rectangle equally into sections. So each board is divided equally. Each board, and there's 2 boards, which is where we get our 2, was divided equally into pieces, or maybe sections, I guess would make more sense, into sections that were 1/5 of a full board. So when each board was divided equally into sections that are 1/5 of a full board, there are enough sections. When two boards were divided into one sections that are each 1/5, there are enough sections for 10 teams. Now, I want you to think about, and I kind of went over it a second ago, how to explain how this model also shows that 2 times 5 is 10. I want you to write that in your own words and then come back. All right, so it says explain how the model in the example shows that 2 times 5 is 10. There's 2 boards. Each has 5 sections. Or you could even say 5 groups of fifths. Maybe that's how you worded it too. 5 groups of 1/5, which is the 5 sections. 2 boards times 5 sections here, 5 sections here, equals 10. So now suppose Mr. Reed's class has 3 full rectangle bulletin boards to show team decorations. So here he has 2. So imagine now there's an extra bulletin board. He now has 3 full rectangular bulletin boards to show team decorations. How many teams would there be in all? I want you to show your solution by writing both a division equation and a multiplication equation. If it helps to draw an area model, you can draw an area model as well. But I want you to pause the video and write a division equation and a multiplication equation based off the example here and what we learned together when answering problems 1 and 2. When you've finished, unpause the video and we'll look at it together. Okay, suppose Mr. Reed's class has 3 full rectangular bulletin boards showing team decorations. So now he has 1, 2, 3. They were divided into fifths before. So how many teams would there be in all now that he has an additional board? So we want to show our solution by writing both a division equation and a multiplication equation. Well, he has 3 boards, and he divided each one into 1/5 sections. When he did that, how many sections were there now for each team? Or how many teams were there for the sections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's now space for 15 teams instead of 10 teams. So we know that 3 boards divided each by 1/5 means there's enough for 15 teams. So we have our division equation. So now let's look at a multiplication equation. Well, if I knew there was 3 boards, and on this board there's 5, and this board there's 5, and this board there's 5, and I didn't want to count, I could easily multiply. If this one has 5, this one has 5, and this one has 5, there's 5 3 separate times. There's 3 times the 5's sections, which again gives us 15. So 3 divided by 1/5 is 15, and 3 times 5 is also 15. Here's our division equation and our multiplication equation to determine how many teams there would be in all. There would be 15 teams. All right, we're going to use this example to answer the last 3 questions. Mr. Reed puts 3 students on each team. The team divides its 1/5 of a board space, so each team gets 1/5 of a board, equally. So each student is able to decorate the same amount. There's 3 students for each team. Each team gets 1/5 of a board space, and they want to divide this 1/5 equally, or each of these fifths equally, for the 3 students. So it says to complete the steps below to see what fraction of the rectangle bulletin board each student decorates. Let's go through the steps together. A, use the square at the right. Shade 1/5 of the square to show 1/5 of the board for one team. So I'm going to shade, like it says, to shade it, I'm going to shade 1/5 of the square to show 1/5 of the board for the team. This is my 1/5 of the board. Part B says divide the square into 3 equal parts to represent the 3 students on each team. So I'm going to take this square and divide it into 3 equal parts. This is for one student to decorate. This is for another student to decorate. And this section is for one student to decorate. So we divided it into 3 equal parts to represent the 3 students for each team. Shade 1/3 of the square so that the overlapping section represents one student. So I'm going to shade 1/3, one of these thirds that we created. I'm going to shade it in so that this overlapping section, which is somewhat purple, I'm going to make it a little more purple with this one, so that this overlapping section represents one student. So here's 1/5 for one team and one student. So we're going to look at what one student will do for the one team. What fraction of the board does each student get to decorate? They get 1 out of how many total pieces when it's been divided in all ways? 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What fraction of the board does each student decorate? 1/15 of the entire board. Each student gets 1/15. So E says 1/5, which is our 1/5, divided by 3. We divided it by 3, equals 1/15. So number 5 tells us to again look at the model in problem 4 and write a multiplication equation that we can use to find 1/3 of 1/5. We have our 1/5, which is a section for one team, and we divide it into thirds, and we found 1/3. We found 1/3 of 1/5. And I've said many times, of means to multiply. We found 1/3 of, or multiplied, our 1/5. So here's our multiplication equation. Write the multiplication equation you can also use to find 1/3 of 1/5. Now let's multiply it out and double check if we're right. 1 times 1 is for the top, and our denominators are 3 times 5. 1 times 1 is 1. 3 times 5 is 15. So is 1/3 times 1/5 the same as 1/5 divided by 3? It is. We get 1/15 both ways. Now 6 is where you get creative. You get to take everything that I've talked about, everything that you've tried, everything that we've modeled together today, and write a word problem that can be represented by the quotient of 3 divided by 1/3. So 3 whole divided by 1/3. So you can write whatever kind of problem that you want. And then it gives us a number line so that you can try and use a number line to solve it. So I want you to pause the video for as long as you need to write yourself a problem, and then use the number line below to solve your problem that you created. And then we can write a multiplication equation that also solves the problem. So go ahead and pause the video now and start it again when you've written your word problem. Okay, welcome back. I would love to hear what some of your word problems are, so if you decide you'd like to type some of them in the comment section and let me know what word problem you came up with, that would be amazing. I'm going to use Mrs. Strom for my example word problem. So I'm going to say that Mrs. Strom, she wanted to do some art and she had a lot of paint. So Mrs. Strom had 3 gallons of paint for art. So there's my 3. Now in my story problem, I need to divide it into 1/3. So I'm going to say that I want to, or she wants to put them into 1/3 gallon containers. So smaller containers instead of gallon size 1/3 gallon ones. So she wants to store the paint in 1/3 gallon containers. So she has 3 gallons and she wants to put them in a lot of containers that only hold 1/3 of a gallon. How many containers is she going to need? Alright, so now I've written my word problem that can represent 3 divided by 1/3. She has 3 gallons and she's dividing them into 1/3 gallon sized containers. So if B asks us to use the number line to solve this problem, then we're going to write a multiplication equation that also solves it. We have our number line that goes from 1 all the way up to 5. Well, we need it to go up to 3 because we are starting with 3 gallons. So our 3 gallons are being divided into thirds. So I need to look at each gallon. So my first one is divided into 1, 2, 3 pieces. So it is divided into thirds. This one, 1, 2, 3, also divided into thirds. And this one has also been divided into thirds. So let's use blue. Here's one container of the paint that's 1/3. Here's another one. Here's another one. So 3 1/3 containers in 1 cup. 1/3, 1/3, 1/3. Here's another 1/3 gallon container. Another 1/3 gallon. And another 1/3 gallon. Now she's divided up 2 of the 3 gallons. So she needs to do it one more time. There's 1/3 of a gallon. Another 1/3 of a gallon. And another 1/3 of a gallon. So she had 3 gallons. She divided them into 1/3 gallon container. How many containers did she need? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So she needed 9 containers. I bet some of you immediately noticed when I was circling. I was doing 1, 2, 3. Then I needed another group of 1, 2, 3. And then 1, 2, 3. So each of those groups had 3. 1/3, 1/3, 1/3, 3 of them. 1/3, 1/3, 1/3, 3 of them. 1/3, 1/3, 1/3. So I had 3 here, 3 more here, and 3 more here. How many groups of 3 was that? There's 1 group, 2 group, 3 groups. So I had 3 groups of 3, or 3 times 3. That's going to help us write our multiplication equation. Write a multiplication equation that also solves the problem. 1 group of 3, 2 groups of 3, 3 groups of 3. 3 groups of 3 gives us 9 containers. So you're able to successfully use a number line to solve our division equation, and you're able to write a multiplication equation that helped to double check that 3 divided into thirds gave us 9 containers. All right, that was today's lesson in looking at how to use division with whole numbers and unit fractions. I hope you're able to follow along. Leave me comments or questions in the comment section if you have anything that you'd like to share. I'd love to hear what kind of story problems you came up with. This is excellent work, and we will build off of this for tomorrow's lesson. Nice job.